Hello, good morning, afternoon, actually. Uh, Sorry about that search bar at the top, but actually, I've been with computers for like since I was, and macOS beta just defeated me with getting rid of that. So, uh, thank you. Uh, Architecture, huh? This is what I'm gonna talk about today. That, right? Boxes and lines. This is what we are used to do. This is a system, right? That's some module, some other module is here. But the problem is that that's not a system. That's just my flat. And the thing we do have about this that if I was buying my flat and I would sell that, it wouldn't convince me a bit to buy it. I don't know anything about this. How big is that bedroom? I have no idea, right? And what does that mean that you have three components over here? And this represents a concept about an architecture, but uh, I would have a lot of more questions. And without architecture, we often settle to kind of seeing it like this, like lines and boxes, lines and boxes. If we are lucky, we might get an occasional flow diagram. If we are unlucky, we get a class diagram. And why, when we just like buy a home or buy a flat, we get all those nice pictures, visualization from this side, from that side, technical specifications, and other stuff and other measurements. But like when we build our applications, we build our games, we build our code, we use this term architecture, but we don't have that. We don't have all those specifications. If you do, you're lucky. So the message that I have for you today is that our lack of perspective, the lack of a wider look and proper communication about architecture really obstructs the view of of our systems. It's putting an artificial flaps on our eyes, just thinking in lines and boxes. Narrows down the thinking about the entire design and inevitably crippling the ability to develop our games. What I want to talk about is why this is happening in our industry. This is much more nuanced topic, and it has a lot of pros and cons on the other side and the history, yada, yada, yada. And I wouldn't go to a satisfying depth on that. So who am I to actually get and have a say about that? My name is Szymon. All my friends call me Simon, so it's easier for you non-English, non-Polish speakers. I worked in games tools and everything, but up to CTO, I'm now working with Playtika as a tech lead. And one thing about me that I love to be wrong. So if you feel that I am wrong today, I would love to have that conversation because we will both learn something. Uh, so let's go for an adventure. And first talk about patterns, right? Because like when we think architecture, we think patterns, right? And we think about this checkbox book. So let's take a pattern. I think everyone knows that one, right? The super favorite, especially in Unity devs. Uh, and what information we are getting from the fact that we know that something is a singleton in terms of an architecture, right? There is only one instance of itself, and the time of creation is unknown. There's an asterisk there. And that's all. This is not telling me anything about my system. If I go to someone and say, oh yeah, my app uses singletons, so is every other app. Even if you're writing modern .NET Core stuff application, you still bind in the dependency injection context something as a singleton. You just wrap that initialization time in a specific manner. The singletons tell me nothing. Even if you like have the multi-manager system, everything is global instance of everything, everything talks with everything else. Just the fact that they're a singleton does not convey that message. So patterns are not architecture. They are a building block, but they are not an architecture. And especially if we actually talk about dependency injection, because when I talk with developers and ask them, oh, what's the architecture of your game? Oh yeah, we use dependency injection. And sure, you can do that. But dependency injection is a $25 term for a 5 cents idea. And there's article by James Shore that kind of tries to demystify that. Dependency injection is just a fancy way of inserting parameters into constructors. It tells nothing about the architecture. You cannot build, by definition, your application as a dependency injection application. So those software patterns can only take us so far, right? I can build my house out of bricks, or I can build it out of concrete. But does my house have a bathroom? What the communication flow is inside our application? The fact that I have dependency injection or I just run everything by singleton doesn't tell me anything about my architecture. It tells me like some basics. So we have this fancy thing, architectural patterns, right? And MVC or MVX. Something. This is actually the original concept of MVC. The view is observer on the model, and the controller changes the model. I know that your perspective on that might be actually different. This has been changed when Microsoft developed the ASP.MVC applications, so the arrows are reversed, but no matter how well you arrange them, you just get into one or the other, which are basically the same. There are, of course, nuances in some sort of how the data is being modified, but really, they don't tell us much about that. So, just coming back kind of to MVC also. So MVC, when we think about MVC, we think about the view, right? We think about how we represent the data of our systems on the screen or terminal or API request, to be honest. So we work in a bounded context. We work in a bounded context of UI, of presentation, of a communication layer. And the same kind of goes with ECS. I know, like, we are game developers. We like nice systems. ECS is great for building systems that drive our game inside. But we cannot really generalize ECS, right? We cannot have ECS answer all the answers about the data flow in our applications. The ECS does not start the application, right? The ECS doesn't do, there is no system that does HTTP requests, right? There's no components that says, oh, that's a get component of that entity, and that means that the HTTP system could make a HTTP request. There is nothing in that system like that. There must be something more to architecture, right? So when I'm, oh yeah, the basics of CS. So when I'm working on a design for a new system or a new feature, and I only focus on putting it inside this ECS package, I'm missing something. Like, there's still something missing. If I just focus on the lines and boxes of that particular system in terms of ECS, I'm not telling the whole story. And like MVC relates to the view, ECS relates to the gameplay. There is perfectly fine to build your game as an ECS instance and then represent it's state by an MVC when you treat the model as the ECS system, right? But there's still something more. And we're arriving somewhere, right? I think this is the level at which most of us get initially when we are designing our applications, right? We look at the feature, look at the closed system, and we do have a room. That room has furniture, that room has a window, and that room has something else. But our application is more than that one system. Our application is more than how that one system communicates with the other system. The same analogy comes to architecture, right? A home is much more than a single room because we do care about other systems. If we forget about them, we are missing on some important part of the entire app. So I would want to bring you to the world of architectural styles. How many of you have heard the term architectural style? There's, yeah, in relation to code, in relation to code. I saw one hand. So welcome. Let's go. Let's start with what we usually get. This is called a big ball of mud. It's actually an official term, in which we describe a monolithic application in which there is no defined flow of control over the components of the system. And how you can get that you actually, how you can identify that you actually have a big ball of mud. Let's say you have a code base, right? And then you see a problem in that code base. So what you go and do, you add another meaningful keyword to that code base. So let's introduce adapters or something. Is this adapter word does this adapter word means anything in your code base? Does controller is always making a specific set of instructions? Is this controller and that controller making the same function? Or do I have controllers that load data and controllers that modify data? If I do have those, then I get a system in which my components doesn't mean anything, and I can just go on and go on like that. And of course, if you have a manager of managers, if you have a central instance in which all of your managers that don't actually manage anything but just do a random collection of things in your code base, this is how you get to a big ball of mud. And there is also that, like, if your improvements are done in isolation because you don't have a layer to abstract your problems, you have a big ball of mud in your project. That I mentioned. Okay. So what is an architectural style? And this was published, Architectural Styles and the Design of Network-Based Software Architectures, in 2000s, actually. And we see, for example, if you are working with backend or something, this definition kind of comes up with microservices and stuff, right? So a style is a coordinated set of constraints that defines the relationships between all of your application. So let's talk about three of them. I just picked three. There are plenty. Not all of them are suitable for game dev. So I just want to highlight the kind of holy trifecta of them as the architectural world kind of sees them right now. I'm going to skip microservices because I don't want to go into infrastructure stuff. I just want to focus on games, like actually the applications that we are building. Let's start with this. This is the microkernel architecture, or named differently, a plugin architecture, which is better on your mind. So the best analogy for that kind of architecture is the IDE. You are all working inside some, for example, Visual Studio, right? Rider, whatever. If you imagine a system like that, an application like that, there is a core functionality to that, and that core functionality allows you to type text into a text box. There's nothing else in that core. All the rest features, the changing of the colors depending on the context, saving and loading the files. This is not core. This is an added feature on top of that. Microsoft Word, the same, right? We are just putting a text into an array, and we can read the text and modify and how it's presented and do something with this. So how can we put into use in games, right? And my favorite example for this are idle games. Cookie Clicker. Anyone played Cookie Clicker? Yeah, right? Don't tell your boss. So an idle game at its core is just a sophisticated counter. We have a value, and that value can get increased, decreased. We can automatically increase that value, and we can automatically decrease that value. But the rest of the functionalities come in form of a plugin, right? At any point, we can disable any of them in any combination. So we can have a plugin that modifies that core, the equation inside that core that says produce one more cookie each minute, right? We can have a transaction that happens in that core that consumes 100 cookies and gives your grandma. We can even make percentage-based changes to that functionality of that core. We can mix and match. We can test in isolation each of that features around the core. Achievements completely outside of the core, right? The communication goes always through the core. We are talking with the core application. Saving all that data, completely not a core functionality, right? I'm an observer on top of a core, and I can initialize the core depending on what data I have. On the file, server, we don't care. But you can see where I'm going. I'm talking about the communication flow inside the application, the control, how the control flows from one point to another. The +1 counter never knows anything about grandmas. And I don't need to have them in separate assemblies, separate DLLs. I'm enforcing that constraint by building my application in such a way that the only way for them to communicate is through that core. Plugin architecture, in my opinion, and I know that because I'm an expert in my opinions, is great if you're looking to build mod-first games for PC. For example, if you look at Remote, right? Everything there is a module that works on top of the ECS of the people and tasks that are running inside that core. That's the core. Rest is exchangeable. Next one is the layered architecture. I think maybe some of them had that in school, but never realized that that's architectural style. Do not confuse that with N-tier architecture. You might have heard that term with relation to server-client communication, yada, yada, yada. Those are the kind of two different things. But the key concept of the layered architecture is that we differentiate layers like a cake, and the communication flow can only go from the upper layer, hello, to the lower, and from the lower to the upper, I didn't make the arrow. We also have an open and closed layers. So we can say that, yeah, my domain layer is an open layer, so I can allow the presentation layer to make a call to infrastructure, but I cannot make the call to persistence layer. This is how we get this. So I wanted to be nice and clickable, whatever. So where do I see layered architecture actually being a best fit? In my opinion, mobile games. Why mobile games? Like if we think about the modern mobile games that we build, they are just like a sophisticated front for making purchases, right? So this is very business-oriented application style. So if we go from the bottom, we could have a device layer that communicates with the device, engine, whatever, makes the I/O operations with file system or whatever, completely abstract that away. On top of that, we would build an infrastructure layer. The infrastructure does logging, does HTTP requests, does like a repository pattern to get all our data, no matter if it's state, no matter if it's configuration. We just have it there in that layer. And what we already can see that the device never has an access to that higher layer, right? On top of that, we can build our systems. We can build a live ops system. We can build a transaction system that allows us to exchange currency to items. We don't care yet what items. The system layer doesn't know that there are coins, that there are skins in your game. The system layer knows that it can make a transaction and exchange one good to another. And the system uses the infrastructure layer to operate. The system can save some file on a disk, but they won't use the device layer. The systems there will use the infrastructure layer as a proxy. We completely abstract that away. This is actually very good for unit testing. We go up, right? We have a business layer. We have an in-game shop when we actually know what currency is. We have collections like cards or whatever, skins. We have tournaments. Maybe there are like many tournaments in our game. And at the top, there's the UI. And that flow control allows us to precisely know that the system on the top layer won't be able to access the system two layers down. This is an example. The fun thing with architecture is that I can build a Gothic house and I can build a skyscraper or cottage, right? You can take whatever combinations, name those layers the way you want, but have that structure and build your features to match that structure. And the third one is something quite new. It was published for the first time in 2005. And it is called the hexagonal architecture. The concept around it was actually quite old because it was known as an onion architecture, usually ports and adapter. Sometimes, but like 5-6 years ago, when we were talking backend development, this was deemed as a clean architecture. So the concept is that we have the domain layer, right? Completely the business layer, the business logic of our applications. I'm talking right now in like Allegro, right? I'm making a storefront. This is the thing. And if I want to talk to sales or to customer support or something, I would have a port to which I talk. And on that port, I attach an adapter or multiple adapters that allow me to do some things. And this allows us to have quite a clear separation of what's going on inside the domain and outside. So we don't intermix our third parties, our dependencies, our stuff with the domain. But in games, I've been in talks in like multiple architects, and this is kind of why I put this on the slide, is that we don't really see a clear benefit of using hexagonal architecture in games. Why? Because those layers of separation, where we innovate in games, is actually in changing the systems, right? And the systems here in the clean architecture are hidden inside the domain. We can run a wrapper, right? We can build a hexagonal architecture for the application, put our game inside the domain, and build the game on top of layered architecture. But then it's kind of losing the clean stuff. So if you go after this talk and Google architectural styles, I've warned you. Like the hexagonal architecture might be not for you, even if you might be tempted to go and read, oh, clean architecture. I can like clean code. I read that book, so it's related. But if you have been inspired by the talk in the morning by Sauce, and you want to create your own engine, maybe hexagonal architecture is actually for you. Because if we go back, right, we have the what Sauce was talking about. We have the domain. We have the core of the engine, of the game engine, and then we can use the ports and communicate with the ports, send the data to the port, and expect an adapter to do that rendering, to do the file operation, to do whatever. Right? This is where it can be useful in game development. So now, what do we do? Like, we know now some stuff, right? We know that we have some patterns, right? We have some implementation patterns. We are using them. They are the building blocks. We have some architectural patterns. They are building the organization structure of some context inside our games. And we have the architectural styles to guide us to build the entire application. What do we do with that knowledge? And there are many moving parts in our games. So when we imagine a new feature, and for example, we would have a layered architecture inside our game, do not just go and draw lines and boxes. This is the UI, this is the server, this is the logic. Take your architecture and piece by piece try to determine in which layer of your system does it go. Maybe it goes on two. Nothing in layer architecture says that one system, one feature can only expose the public API, the communications on one layer, right? Then maybe it comes on two. If it goes on two, maybe I have two systems. Maybe I have something completely different. It makes you completely think and reiterate how this entire new feature fits into the system. What if I told you that Morpheus never actually says, what if I told you, in any of the Matrix movies? This is like meta memes. But there is more. There's completely more to game architecture than just the code, right? Because the game architecture, the architecture as a whole, is the environment we work with. The engine, the plugins, the third party, that one publisher that we don't really like to work with, the concept of the game we work upon itself is architecture. The team I have, the team I work with is architecture. Do I have 7 designers and 2 programmers, right? Do I have 10 programmers and no artists? All of those decisions influence how we build our systems, how we build our new features inside this entire system. And the organization itself also defines our architecture. So Gregor Hochpe is now, I think, a solutions architect in AWS, wrote in his book that to be an architect is to ride the architect elevator. And that elevator goes down to the server room and up to the CEO with all the floors in between. Because the role of an architect is to answer questions by our code, by our design, to facilitate the needs of the entire studio, of the entire company. And this is extremely important when we scale, right? There is a Conway's law that says that the complexity of the code that we write, the complexity of our engineering scales up with the complexity of organization. If our organization is complex and has a lot of hurdles you need to get through to get a decision, it gets reflected into how our applications are built down there. The game we build is not just the code, and the architecture of that game is not the code, and the code is not the architecture, and the game is not its architecture. Our architecture needs to answer the questions, like how do interactions within the systems inside the code work, but how also we facilitate the interactions with other teams. How will they operate the game? how QA can test it. All of those answers will make us make informed decisions when we are designing the new features. And why bother, right? Because like this is a theory. So at the end, you just might ask yourself, yeah, Shimon, cool story, bro, but I need to deliver, right? We are a business. We need to deliver some stuff. We need to deliver games. We have players that are anticipating stuff. We have that manager that wants you to work overtime. So why should I just not plop another singleton on top of that, right? My answer to that boils down into the concept of a livable architecture. Like at home, you want yourself, your family, your guests to feel comfortable, right? To feel safe. Home in which plans you and designs like you put significant amount of time because you're gonna spend a lot of time in that place. So and the home is the place that not only makes you feel comfortable at, but also makes you be willing to come back to, right? When you come back from work, you're coming to you want to come to your home. That all the observations. Programs must be written for people to read and only incidentally for machines to execute. We build our games by expressing it as a code. We write that code for ourselves to read later. Even AI system would come now and take your jobs now. The AI would not have to write a comprehensible code that you need to read. The goal of an AI would be to make a game, a system that runs fast, delivers fast, but no one needs to read that code. Our job as architects, as leaders, as programmers, as everyone in the team, is to write our code, and by code I don't mean just the lines of code, as something that's comprehensible for us now and for us in the future. So all that builds kind of an infrastructure to challenge ourselves, to collaborate better and empower creativity. We want to come back to a code base that makes us feel inspired, that we feel we can make something out of. Those environments, like a fireplace in a cozy living room, bring people together, right? And allows us to make the best games we can, because if we know the tools and we use them well and we communicate about our design efficiently, we can make our home, our code feel like home. Thank you very much. If you have any questions, now it's good time because I'm actually on time, which is great. It's also a tradition to now go to the app and leave a thumb up on the review. And if you don't agree with me or would like to discuss something better, want to like go into examples, I'm gonna be at Playtika booth from now on for like the next hour or two, and come and chat. There's a question there. Can we have a mic to?
Hey, thanks for talk. Could you please elaborate more a bit between the differences between plugin-based architecture and hex architecture? Because to me it seems like the hex architecture seems to be like
Yeah, right.
a plugin architecture with some precise precise meaning of the plugins, which is kind of the same for me. But you just say that there is this type of plugins that just solve this issue.
Yes, yeah, completely agree with that perception, right? So the plugin architecture gets you to try to absolutely minimize the crucial amount of your code base and moves all the features out of that core. In the domain architecture, in the hexagonal architecture, this is not about extracting features, it's about extracting dependencies. Entire system, the entire domain still sits inside that core, separated however. This is why it is very useful for services, like a backend. I'm gonna make a backend, I have the entire business logic inside my domain. And usually with microservices, what you do is that you separate your business domain into small chunks and make one service responsible only for that part of domain. What you abstract out in this style, only the dependencies. So you don't care if you're using HTTP or you're using gRPC or something. And for games, if we want to use either, right? We would have the entire game in the domain part, in here, in this model, or we would have just the smallest feasibly chunk. Like if you think Mario Brothers, the Super Mario Bros, the original one, there is a guy running right, and he can jump. That's the entire core. In hexagonal architecture, it would be the entire game, but the rendering for the NES and the rendering for whatever platform was released to would be those two different components. I know it looks similar. It was confusing for me at first too, but that's why some people prefer the microkernel name for that.
Okay, I have another question, if I may, because if I think about plugins architecture-based architecture, as you mentioned, I think of Unreal as a very typical example of that. But the question is, how do you solve the issue of having the actual game composition, I would say? Because usually when you work with Unreal, let's say, you can separate a lot of stuff to separate plugins, right, to be able to reuse it later. But at some point, you need some piece of code that will connect all of those and make the actual game. Which, sure, still, this is one of the, let's say, plugins. Let's say you call this plugin a game, which connects all of the plugins together. But it doesn't that in the end give you the pile of mud, as you call it? But it's just instead of being a pile of mud, it's a pile of plugins connected to each other.
All that stuff that we have talked about is only a way of representing some stuff. There are the tools. Like if we look at the example with architecture of buildings, right? I can present the same concept of a building in that form and not in another form. Nothing says that that we have only one style guiding us completely to stuff. This is all based to your needs. What I'm giving you is the tool set. I'm giving you the ideas on how can you actually think more than that. I'm not, there is, and believe me, there are no silver bullets. There is gonna be an engine constraint that won't allow you to do one thing or another, right? So just pick the tools you need. If you think that one style is better for you than the other, the rest is just an implementation detail.
Thank you.
Cool. Any other questions? There's a question there. Thank you.
Hi. So how come you are not afraid to build on top of that microkernel architecture, where you like have so many things depend on like one kernel, and when it comes to some kind of refactoring, it all can break down?
Yeah, that's a really good thing. When we the entire thing about microkernel is that you really want to make it extremely small. And this is kind of also working really well with kind of the TDD approach. You know that your design choices influence how your API to work with that. And if your kernel is small enough, it's very testable. If you cover it with tests, the tests give you confidence that any changes you make will preserve the functionalities you would want to have. So the question of how can I be so sure and confident to make the entire application communication drive to that core are answered by the techniques I'm using to develop that, right? Especially with microkernel. I would completely advise you to go with 100% path coverage in your unit tests, right? This is how you build confidence. The architecture doesn't give you confidence. When you look at your building plan, how you read the plan doesn't give you confidence. What gives you confidence is that the architect who went there, they chose this kind of concrete and this kind of structure that allows that roof to still hold 1 ton of snow. So for games, that confidence you get by your tools that you're using to implement, for example, unit tests.
Okay, thank you. And you've also said that hexagonal architecture may not be the best for the games, but there are also like two other, like we've mentioned microkernel, and there is also this layers architecture. Which do you think is more like general purpose one for the games?
For me, it's a layered architecture, especially if you are not experienced with building systems. I think layered architecture is really easy to understand by anyone in your team because you just said, yeah, this is not our code, this goes into this layer. This is the business code, this goes into this layer. This doesn't have UI, this goes into this layer. This is very easy. And it's very easy to start with the classic 3 or 4 layers that we read upon in the book. Everyone kind of gets that, and it's very easy to add another layer later because your architecture in software is constantly evolving. So that's like my personal preference, and this is what I'm pushing into very unexperienced teams. But if you are more experienced one, going into microkernel is actually very tempting. I had one project on that. Very cool code, but you need experienced engineers to kind of understand what is the core. We so often I see developers have like a assembly which says common, and it has half of the game in this, or that common assembly knows about all the features around that because of course I put the enum with window IDs in there for some reason. That's data. That's not code. Don't do that. So that requires you to have a more mature engineering team.
Okay, thank you very much, and I feel really like encouraged to check it out. So thank you.
Thank you. That's nice. Do we have any other questions? There is a question here. Hello.
Hi, thanks for the talk. So my question is, how do you keep your architecture up to date with the changing gameplay stuff, the changes that don't come from the tech, but rather from the designer team, etc., when suddenly my neatly little partitioned features need to talk to each other and neither of them is part of the microkernel?
Oh yes, the change request, right? The ever evolving need to change my neat, clean code. The truth is that when I build a house, I'm not gonna change the foundation after Christmas, right? But with games, this is kind of anticipation. You can only be prepared to be ball wrecked so much, right? You can build your architecture to withstand 1 or 2 complete changes of the initial concept. The role of the architecture, as I quoted Gregor, is to understand how business think. Architects are not programmers only. You also think like business, you think like designers, you think like everyone in your company. You should be able to communicate with them. So how do you do this? you talk with the people. I know, like we spent 4 years in high school, in university, just to not talk to people, and now this guy tells you to talk with the people. Horrible. So yes, you need to communicate. You need to communicate openly and be very open, not with your devs, not only with your devs, good, but also with all the business people around that, what they want to build, and kind of out of experience, communicate about this. All of this won't come to you in a month, in a year. This is a structured thinking that you build with. I want to give you the toolkit. I want to give you the keywords that you want to Google if you want to get better at this. But I'm not gonna solve the problem that your designer said, hey, I know we were making this match tree, but I would really want a MOBA. This is like completely new application, right? If someone would like on a real thing, right? You want to build a car, and now you're saying we are building a jet. I won't change the architecture of a car to transform into a jet. There's only so much I can actually do. So yeah, you need to be very open about that stuff.
Thank you.
Any other questions? If no, then feel free to catch me at Politica booth, and have a great rest of your conference. No, there is a question here.
I think about kernel architecture, and it's look like thing for a small games like a cookie clicker.
Yes.
Because if you have a, I don't know, extraction shooter, so you have a lot of kernel mechanics, and looks like you need another architecture. Like you said, hexagon architecture is not really good for games, so we have only one choice: layers, right?
No,
No?
there are many more things. On my GitHub, which is very at the end of that presentation, and I need to click about this. I'm gonna have the slides here on my GitHub, so make a screenshot out of this. I linked a couple books, which are great read. There are many more styles. There are pipelines, right? There's actually I'm now working with another architect trying to kind of reimagine microservices as a client thing, when you kind of get this domain separation by design and communicate with the standard APIs. There is much more. And also, no one tells you that that you need to conform to the norms. I have a pink hair. I don't conform to a norm. I can imagine my own system, and I can build my own architecture.
It's hard way.
Yeah, the architectural style is the set of constraints that define the flow in our application. We can develop our own. But also, I think it would be an actually very interesting study case to try to take that 3D shooter into a microkernel application. I know, this looks right, but that's a challenge. That's a challenge. I'm gonna take it to workshop. I'm gonna try to make that work because again, this is just the form. This is just the mold we put the stuff into. Sometimes it's impossible. Of course, we may have too much dough for
It just looks like a big ball of mud just in kernel.
Yes.
Nice.
We can end up with that. But
Or
maybe
multiple kernels. I'm not
yes,
sure.
maybe multi-kernel. Maybe you just invented a multi-kernel plugin architecture. That happened here. First, Wikipedia notice. Please notice us.
Okay, thank you.
One more question here. I think we still have like 5 minutes time, right? Thank you.
Hello. Thank you for the talk. And actually, I have like interesting question about, can we actually mix architecture? Because sometimes we have like some architecture, but some architectures like works for this particular like games or subject or feature, and some architecture like works better with another architecture, and can we actually mix the architecture? Yeah.
Yes. This is actually also the approach I do in mobiles. Mostly, there is first the layer of an application. When I'm thinking about the mobile game, I'm not thinking about the game, I'm thinking about application. And first thing I do is I take there is a pipeline architectural style which says I'm communicating from one point to another through a defined path, right? Kind of like finite state machine with a quirk, right? So I have wrapped the entire application into that pipeline. Then inside that pipeline, I build layers, right? And that's how I do some stuff. And inside the gameplay, when my application finally reaches the core gameplay mechanic or something, I can switch completely to something different. The pipeline is now my system. I have an infrastructure layer, I have logging there, I have whatever, which is on which the pipeline is built, but I can interact with it completely differently. The key point that you need to remember is that if you do stuff like this, write it down, make sure you understand it, everyone in your teams understand it, and when you take a new feature to your workshop, you are actually thinking in the term of this multi-tiered system, right? This is the harder part. Because like if you have just one style, let's just go. But if you have a multi-tier system, you are gonna write into much more complex design phase. And sometimes it's not the best thing. So sometimes it's best to just fit into ourselves into the mode, right? So this is, again, architectural thing, it depends.
Thank you.
Okay, so, no, there's one more question. Hello. We have time for that one more question.
Okay, so let's say you have some complex architecture in your company, and how would you introduce new guy to that architecture to no screw things up at the beginning or something like that?
I actually want to make a talk about that, a completely separate thing, because I think there is a way that your code, that your API should guide how you use your system. I think even if we think about like the plugin, the layers, the pipes, the whatever, the mechanism that drives the newcomers into your code base is the API. The API should tell you the story of how my systems communicate. If I screwed up on my API, I'm 100% sure that some newcomer gonna come and gonna like some reference, some DLL they weren't supposed to do some, and now the unit tests fail. So yeah, this is a much more complex question, but the shortest answer is that your API guides your developers.
Okay, thank you.
I think we are. No, hello. It's for the recording.
You. So the question is, did you have any experience with completely clean architecture, rigidly followed in your team in games, and how was the experience with it, and what were the downfalls, so the issues?
Yeah, so the extreme benefit that you get from an extremely defined architecture is that after some time, when people start to use it, they feel it in your heart. So the entire team is kind of on board with you. We talk about a new feature, something that we want to add, maybe extend some module, maybe extend something, and everyone knows we start a discussion from much a higher level. This is like a enlightening moment for the entire team, because your team kind of acts as one, and it says it is not only in the features themselves, but also how the code is written. This is the extreme benefit, and this is why I kind of want to preach about trying to define your architecture. And what are the drawbacks of that? Is that sometimes simple mistake can be very costly. And you need to kind of pay attention to the process of review. Having this a defined architecture, I would really encourage all the CEOs there on the conference to think about having a dedicated architect who can define rules of how we monitor our architecture, how we monitor the health of our code base, how we monitor that all those guidelines that we put into place are followed. Because this is a group effort. Architect is just a leader. Architect is just a person that steps up in front of the team and says, hey, follow me, right? but we sometimes need to look back. And this task can be very taxing, especially if you don't have a separate architect. You usually have like one senior developer, right, and 3 juniors, so 12 juniors. And that senior developer is also doing accounting. Yes, we're finishing. So yeah, separation of responsibilities, as in systems. That's hard.
Thank you.
Thank you. So we need to finish up. I'm going to be down there in Playtika booth, so let's catch up later. Thank you very much.